BSL-3 laboratory is a critical shield against airborne pathogens. Biosafety Level 3 BSL-3 laboratories are specialized containment facilities designed for handling microorganisms that can cause serious or potentially fatal diseases in humans, particularly those that can be transmitted through the air. These laboratories play a vital role in modern biomedical research, disease surveillance, vaccine development, and public health preparedness. Unlike standard microbiology laboratories, BSL-3 facilities incorporate advanced safety methods to protect laboratory personnel, the surrounding community, and the environment from accidental exposure to infectious agents. The need for BSL-3 laboratory arises from the nature of certain pathogens that can spread through aerosol or airborne particles. Diseases caused by organisms such as Mycobacterium tuberculosis, SARS-associated coronaviruses, highly pathogenic influenza viruses, Coxiella bruneti, and several other infectious agents require enhanced containment because inhalation of even small numbers of microorganisms may result in infection. Scientists working with such pathogens must therefore operate in an environment specifically engineered to prevent their escape. One of the defining characteristics of a BSL-3 laboratory is restricted access. Entry is limited to authorized and specially trained personnel who understand the risks associated with the handling infectious materials. The laboratory is usually separated from the general traffic areas and equipped with self-closing double door entry system that provide an additional layer of containment. Before entering, personnel must follow strict protocols designed to minimize the possibility of contamination. A key feature of BSL-3 facility is the use of biosafety cabinets, particularly Class 2 or Class 3 cabinets. These enclosed workstations provide a controlled environment where infectious materials can be handled safely. The cabinets use carefully regulated airflow and filtration systems to prevent microorganisms from escaping into the laboratory atmosphere. Any procedure likely to generate aerosols such as pipetting, centrifugation, or mixing cultures is conducted within these cabinets to reduce the risks of airborne exposure. Another essential engineering control is the maintenance of negative air pressure within the laboratory. Air is designed to flow from clean areas into the containment area, ensuring that contaminated air cannot escape to the adjacent spaces. If a door is opened accidentally, air continues to move inward rather than outward, effectively containing potentially hazardous microorganisms. Before being released into the environment, exhaust air passes through high efficiency particulate air, that is HEPA filters, which remove microscopic particles and microorganisms with exceptional efficiency. Personal protective equipment, which is also designated as PPE, forms another critical component of biosafety. Laboratory personnel typically wear protective gowns, gloves, eye protection, and respiratory protection such as N95 respirators or equivalent devices. These barriers reduce the likelihood of exposure through direct contact, splashes, or inhalation of infectious aerosols. PPE serves as the final line of defense, complementing the engineering controls already present within the facility. The operation of a BSL-3 laboratory depends not only on specialized equipment but also on strict laboratory practices. Personnel receive extensive training in biosafety procedures and emergency response protocols. Great emphasis is placed on minimizing aerosol generation, safe handling of sharps, proper waste disposal, and routine decontamination of work surfaces and equipment. Infectious waste is sterilized, often through autoclaving before disposal, and regular inspections, maintenance of maintenance of the safety systems and adherence to standard operating procedures designated as SOPs ensure that containment measures remain effective at all times. Hand hygiene is another fundamental practice in BSL-3 laboratories. Hand washing sinks are strategically located near exits, allowing personnel to wash and disinfect their hands before leaving the containment area. Decontamination procedures may also involve chemical disinfectants, ultraviolet sterilization, or specialized cleaning protocols, depending on the nature of the work being conducted. So, the ultimate purpose of a BSL-3 laboratory is to facilitate important scientific research while maintaining the highest standards of safety. These facilities enable researchers to investigate dangerous pathogens, understand disease mechanisms, develop diagnostic methods, test vaccines and therapeutics, and prepare for potential outbreaks. So, by combining advanced containment technology, rigorous safety practices, and highly trained personnel, BSL-3 laboratories create a secure environment where critical research can be conducted without compromising public health. So, in conclusion, BSL-3 laboratories represent a sophisticated balance between scientific advancement and biosafety. They are indispensable in the global effort to combat infectious diseases and protect society from emerging biological threats. Through carefully designed containment systems, strict operational protocols, and unwavering attention to safety, these laboratories allow scientists to study potentially dangerous pathogens while ensuring that both people and the environment remain protected. Thank you.